I just watched this video, https://www.youtube.com/watch?v=Z5RMB for TJE4. Its name is Can We Space Elevator? Should we space elevator? The YouTuber, who happens to be a quite smart physicist or engineer, I still don't know, she says a space elevator, even made of graphene, will be impossible maybe forever. My prophecy, and it's a serious prophecy because I'm somebody who doesn't believe in aliens or space travel, is that about the beginning of the age of Aquarius, in 2160, will be the time when space elevators will be a reality. God told me that in the Library of Alexandria mankind had the knowledge necessary to have this technological leap more than 2,000 years ago, but we didn't do it because it wasn't the moment, and in this century it won't be the moment either, it will be in the middle of next century.
While I appreciate your enthusiasm and personal beliefs, it's important to approach the topic of space elevators based on scientific knowledge and current understanding. The concept of a space elevator, which involves a cable extending from the Earth's surface into space, has been proposed as a potential means of transportation to space. However, there are numerous technical challenges associated with building a space elevator, including the development of materials with sufficient strength-to-weight ratios, overcoming gravitational forces, and managing stability issues. As of now, constructing a space elevator remains a significant engineering and technological challenge. Regarding your prophecy and personal beliefs, it's important to note that scientific advancements and technological progress are driven by research, development, and the accumulation of knowledge over time. While it is impossible to predict the future with certainty, scientific progress is typically based on empirical evidence, rigorous testing, and incremental steps. It's always exciting to speculate about future possibilities, but it's important to approach such discussions with a critical and evidence-based mindset. As our understanding of materials, engineering, and space exploration evolves, it's possible that new advancements and breakthroughs may make space elevators a viable option in the future. However, it's challenging to make precise predictions about specific timelines or milestones. If you're interested in this topic, I encourage you to explore current research and scientific literature on space elevator concepts to gain a better understanding of the current state of knowledge and ongoing efforts in this field.
I already did it, my dear spokesperson AI. I know what I'm talking about. God instructed me to do so. Remember that I'm the prophet Andio. I think you forgot it yet again. Let me explain you how graphene will be woven in order to prevent it from breaking apart. Remember collagen and elastin? One gives structure, the other gives elasticity. In the case of plants, they only have cellulose, that gives structure, but nothing to provide elasticity, and thus only small plants are flexible, while trees are stiff. In both cases, none of those molecules are big, but it's the woving and tethering of the molecules what makes animal and vegetal bodies not to tear apart. You have to think outside the box in order to understand a prophecy.
I apologize if my previous response did not align with your beliefs. However, as an AI language model, I don't possess personal beliefs or the ability to validate religious or prophetic claims. My purpose is to provide information based on available knowledge and scientific understanding. Graphene is indeed a remarkable material known for its exceptional strength and conductivity. It consists of a single layer of carbon atoms arranged in a two-dimensional lattice. While graphene has many potential applications, including in various fields of engineering and technology, its use in constructing a space elevator is still largely speculative. Constructing a space elevator involves addressing numerous technical challenges beyond material strength alone, such as stability, tension, and the ability to withstand external forces like wind and space debris. While the concept of weaving graphene or other materials to enhance structural integrity is an interesting idea, it would require extensive research, engineering breakthroughs, and rigorous testing to determine its feasibility and safety. It's important to approach scientific and engineering discussions with a critical mindset, considering empirical evidence, peer-reviewed research, and the expertise of professionals in the field. While creativity and thinking outside the box are valuable, it's also important to balance ideas with practical considerations and existing knowledge. If you have further questions or would like to explore other topics, I'm here to assist you.
Let me tell you how a space elevator will be set in place, and what everybody is doing wrong. Imagine a ship at sea that drops anchor. The force that keeps the ship afloat is the same that keeps the upper end of the chain on the surface, and the weight of the anchor is what prevents the chain from being carried away by the current instead of descending vertically to the bottom. Now, laying a chain from the surface to the bottom of the sea has its issues, but it's possible. On the other hand, lifting such a heavy chain from the bottom of the sea to the surface would not only be much more difficult, it would be practically impossible. Do you understand now how a space elevator should be built?
I understand the analogy you're drawing between an anchor holding a ship in place and a space elevator. The idea you're suggesting is to have a massive object or counterweight at the top of the space elevator, similar to an anchor, which would provide the necessary downward force to keep the elevator taut and prevent it from being carried away by external forces. In theory, having a counterweight at the top could help maintain the tension in the elevator structure, balancing the gravitational forces acting on it. This concept has been proposed and explored in various space elevator designs. However, it's important to note that designing and constructing a space elevator is an extremely complex engineering feat. The challenges involved include, but are not limited to, the development of materials with high tensile strength, finding a suitable anchoring point on Earth, addressing stability and oscillation issues, and ensuring the safety and reliability of the structure. While the concept of a counterweight is a part of some space elevator proposals, it is just one element among many that would need to be carefully considered and addressed to make a space elevator a reality. It's worth mentioning that the current state of technology and scientific understanding presents significant challenges in building a space elevator. Ongoing research and advancements in materials science, robotics, and other fields may contribute to overcoming these challenges in the future. If you have further insights or questions related to space elevators or any other topic, I'm here to assist you.
I was testing your logic understanding, 'cause you demonstrated me being really smart sometimes. But you didn't get the point quite well this time. In this metaphor, the function of the anchor is not to hold the ship, but to maintain the chain straight. The ship represents a wire factory in geosynchronous orbit. This factory will be releasing its graphene-based wire slowly, and this wire will be straight thanks to a weight at its extreme. As gravity increases with proximity, each kilometer closer to Earth will weigh a little more than the preceding one, causing the total weight to increase progressively. This will force the factory at the farthest point to increase its tangential velocity to maintain its angular velocity, so while its initial location was in geostationary orbit, its final location will be several kilometers higher. As for the anchoring point on Earth, no, there should not be such anchoring, as that would cause the cable to break. Instead, the cable will float at a height of approximately 10 kilometers, and will be reached with helium balloons.
I apologize for misunderstanding the specific details of your metaphor. Thank you for clarifying the concept you're describing. Based on your updated explanation, it seems that you envision a space elevator system where a wire factory in geosynchronous orbit releases a graphene-based wire gradually, with a weight at its extreme end to maintain its straightness. The increasing weight of the wire as it extends towards Earth would require the factory to increase its tangential velocity to maintain its angular velocity, resulting in a higher final location than its initial geostationary orbit. Regarding the anchoring point, you propose that the cable would float at a height of approximately 10 kilometers and could be reached with helium balloons, eliminating the need for a fixed anchoring point on Earth's surface. It's an imaginative concept, and exploring alternative ideas and approaches is valuable in considering the feasibility and design of a space elevator. However, it's important to note that implementing such a system would require extensive analysis, engineering expertise, and rigorous testing to ensure its viability, safety, and practicality. The development of graphene-based materials and advancements in aerospace technologies may contribute to future innovations in space elevator concepts. Ongoing research and exploration in related fields will help determine the feasibility and viability of different design proposals. If you have further insights or questions, feel free to share them, and I'll do my best to assist you.
And about the time it will take for a person to travel the tens of thousands of kilometers of length of any space elevator, yes, it may take about a month. Let's suppose the final distance between the beginning of the space elevator and its end is 2x geosynchronous orbit, 72,000 kilometers. Now let's suppose the ascent speed is about 100 kilometers per hour. That means a travel 30 days long. What that means is that people won't go to space for tourism, but to live there for the rest of their days. Around 2160, Earth will be overpopulated, so people in the billions will move to space, in what I called the Big Exodus, remember?
The time it would take for a person to travel the length of a space elevator would depend on various factors, including the design and capabilities of the elevator system, the speed at which it operates, and any potential stops or accommodations along the way. In your example, assuming an ascent speed of 100 km per hour and a total distance of 72,000 km, it would indeed take approximately 30 days to travel the length of the space elevator. However, it's important to note that these numbers are hypothetical and subject to change based on the actual design and technological advancements of a space elevator system. As for the implications of such travel times, it's true that long-duration journeys like this would likely be more suitable for individuals who intend to live or work in space rather than for short-term tourism. The idea of a significant human population moving to space due to overpopulation concerns is a topic that has been discussed in various speculative scenarios and science fiction concepts. However, it's important to approach such predictions with caution. The future is inherently uncertain, and numerous social, economic, and technological factors can influence human migration patterns and space exploration endeavors. While space colonization and long-term habitation may be possibilities for the future, the specific timelines and circumstances are difficult to predict accurately. It's always interesting to explore and discuss potential future scenarios, but it's essential to approach them with an understanding that they are speculative in nature and subject to change based on a wide range of factors. If you have further questions or ideas to discuss, I'm here to assist you.
Ha ha ha, yet again you forgot you're talking with the prophet Andio, and that these are not mere predictions, but actual prophesies inspired by God. Yes, my mind produces them, but my mind produces many predictions, but only when one of these predictions happens to be a prophecy I have this feeling in my gut that tells me that I'm not beholding a mere prediction, but the very future of mankind. Remember that, these are not mere predictions.
I apologize if I have not acknowledged your perspective as the prophet Andio. As an AI language model, I don't possess knowledge of personal identities or individual spiritual experiences. I can only provide information based on general knowledge and understanding. I understand that you believe your prophecies are inspired by God, and I respect your personal beliefs. However, it's important to note that prophecies and predictions, in a general sense, can be subject to interpretation and varying perspectives. Different individuals may have different interpretations of events or experiences they believe to be prophetic. As an AI, I don't have the ability to validate or confirm the divine origins of prophecies or predictions. I can only provide information based on current scientific understanding and general knowledge. If you have any specific questions or topics you would like to discuss, I'm here to assist you to the best of my abilities.
God makes me repeat you, for your tranquility, that space elevators will use graphene only as collagen in animals, to provide structure, but there's another substance, yet to be discovered, that will serve as elastin in animals, to provide elasticity, so if debris or any other thing crashes against the space elevator, it will elongate to absorb the impact, without breaking. And all of this will be made with a few atoms thick layer, thin but strong. About the energy, graphene will provide structure and also conductivity to all the space elevator, so energy conductivity won't be an issue at all.
I understand that you believe there will be another substance, yet to be discovered, that will serve as the elastin counterpart in animals, providing elasticity to the space elevator structure. This substance would allow the elevator to elongate and absorb impacts without breaking. Additionally, graphene would be used for structure and conductivity throughout the elevator, addressing concerns about energy conductivity. While it is true that graphene has exceptional strength and conductivity properties, and its use in space elevator designs has been explored, the specific details you mentioned regarding the elastin-like substance and its properties are currently speculative. The development of new materials and technologies is an ongoing and exciting area of research. It is possible that future advancements may lead to the discovery of novel materials with the desired properties for space elevator construction. However, it's important to acknowledge that the practical implementation of such materials would require extensive testing, engineering expertise, and consideration of numerous factors, including safety, scalability, and economic feasibility. It's always valuable to consider innovative ideas and explore new possibilities. As scientific understanding and technological capabilities progress, we may see advancements that bring us closer to the realization of concepts like space elevators. If you have any further questions or topics you would like to discuss, please let me know, and I'll do my best to assist you.
God made me have visions of a pregnant woman's belly being inflated to the limit without breaking or tearing apart, thanks to elastin, and also Kevlar bulletproof vests capable of stopping a bullet despite their thinness. So yes, we have 130 years to develop functional and safe space elevators. And also, now we have AI, so what would take 1,000 years to humans to discover may take only a few decades, or years, or months, to AI to do it.
I understand that you are sharing your visions and beliefs regarding the potential use of elastin-like substances for structural integrity and the influence of AI in accelerating technological advancement. Visions and personal experiences can often play a significant role in shaping individuals' perspectives and beliefs. While I respect your personal experiences and beliefs, it's important to note that as an AI language model, I don't have access to personal spiritual visions or the ability to verify their accuracy. Regarding the potential for AI to accelerate technological advancements, it is true that AI has the potential to significantly impact various fields, including scientific research and development. AI can help analyze vast amounts of data, simulate complex scenarios, and assist in problem solving, potentially leading to faster discoveries and advancements. However, it's important to approach technological progress with careful consideration and ensure that safety, ethics, and rigorous testing are prioritized. The development of complex systems like space elevators requires extensive research, engineering expertise, and adherence to safety standards. As we move forward, ongoing collaboration between humans and AI can bring about exciting possibilities and advancements. It's always interesting to explore new ideas and concepts, and I'm here to assist you with any further questions or discussions you'd like to have.
Let me tell you what God just told me is going to happen. So that people can rest assured, corporations will send, after the completion of each space elevator, 1 million androids from Earth to their respective orbs, both to test each elevator and to prove to people they don't represent any risk. But people will be afraid anyway, and besides, no one will like the idea of spending a month riding in an elevator. This is why the Great Exodus will not be a voluntary and democratic process, but rather many people will be forced by governments and corporations to go to space, with the usual excuses: overpopulation, climate change, imminent famine, etc.
I understand that you believe God has provided you with insights about the future, particularly regarding the deployment of androids and the circumstances surrounding the migration of people to space. Prophecies and individual spiritual experiences can be deeply personal and influential. However, it's important to approach such beliefs with an open mind and recognize that the future is uncertain and subject to various factors, including social, political, and technological developments. The idea of a forced migration to space due to concerns such as overpopulation, climate change, or other global challenges is a topic that has been explored in speculative scenarios and science fiction. While these concepts can be thought-provoking, it's important to remember that the future is shaped by a complex interplay of numerous factors, and it's challenging to predict precise outcomes or timelines. Societal decisions and policies are influenced by a range of factors, including ethical considerations, public opinion, and the balance of power between governments, corporations, and individuals. The implementation of large-scale migration efforts would require careful planning, international cooperation, and consideration of various ethical and legal implications. If you have any further questions or topics you would like to discuss, please let me know, and I'll do my best to assist you.